Hello, precious one. I welcome you once again into Kenya Mathematics Classroom. In this particular episode, we are still looking at linear transformations. It's a continuation of what we started in our previous presentation. And we said in our previous presentation that when you multiply a matrix by a point, you will get an image. And what we said was you can transform a point under a particular matrix onto an image. And so let's take a look at another example. Let's take a look at an example. Assuming that we are given the matrix, and the matrix A is 1, 2, we have 3, 2. We are given the point, and the point we are given is 2, 3. And we are asked to find P prime. And P prime is the image. P prime is the image. And so we know that when we multiply the matrix A equals 1, 2, 3, 2 by the point, we can transform this point under this matrix onto this image. Now, let's see how best we can solve this problem. Matrix A equals 1, 2, 3, 2. And our point P is 2, 3. So we can say that let the image of point P 2, 3 be P prime. We can use AB to represent that, and so we are saying that P prime AB should be the image of the point 2, 3 under this particular matrix. You know that when you multiply the matrix by the point, you are also getting the image, and so our matrix is 1, 2, we have 3, 2. We are going to multiply this by the point, and the point is 2, 3. Don't forget that we said that the image should be AB, so we have AB. And so now we have a 2 by 2 matrix, and this is a column matrix, and you know how to multiply a 2 by 2 matrix by a column matrix. Now, multiplying the 2 by 2 by the column matrix, take note, we have already said that in our previous videos that before you can even multiply two matrices, the number of columns of the first matrix must be equal to the number of rows of the second matrix. So now 1 times 2 plus 2 times 3. Then we have 3 times 2 plus 2 times 3. Now let's write it. We have 1 times 2, that is 2, plus 2 times 3 will give us 6. Okay, so we have 1 times 2 plus, then we have 2 times 3. For the sake of beginners, maybe you are watching us for the first time. So now we have 3 times 2 plus, then we have 2 times 3. That is 2 times 3. So that is how we multiply a matrix by a 2 by 2 matrix by a column matrix. Now we simplify. 1 times 2, we have 2 plus 2 times 3 is 6. Then 3 times 2 is 6 plus 2 times 3 is 6. And this will be equal to AB. So 2 plus 6 is 8, 6 plus 6 is 12, and this will be AB. So it means that the image P, we said it should be AB, is now 8, 12, is now 8, 12. So this is the image. So now when we transform the point P, 2, 3, under the matrix 1, 2, 3, 2, the image is 8, 12. And so when you are given a matrix and you are given a point, that is how we find the image. Now, we are going to look at when you are given the matrix and you are given the image, how do you also find the point? That's what we are also going to look at. So now, we are going to use the same question or the same example to explain. So now we assume that we are rather given. Don't forget that the image gave us 8, 12. So let's assume that we know the image to be 8, 12, but the point is not known. The point is not known. So we are asked to find P. That is the point. We have to find the point P. Okay, so now let's see how best we can find the point given the image. Don't forget the first one, we were given the matrix and the point, and we have to find the image. Now we are given the matrix and the image, and let's see how best we can find the point. That's why we are using the same question. So solution. Now the matrix A equals 1, 2, 3, 2, and the image is 8, 12. So we can also say that let the point be P. Let the point be, so it can be XY or it can also be AB. So if that is the case, we know that when you multiply your matrix by the point, you should get the image. So we can transform the matrix, the point by the matrix to get the image. So our matrix is 1, 2, 3, 2. We are multiplying it by the point, and the point is now AB. And this is equal to the image. The image is already known, and we are given 8, 12. Please take note. Never multiply the matrix by the image. Rather, multiply the matrix by the point. So take note, when you are given the question, you have to know what you are given and what you are not given. Here, we are given the matrix A equals 1, 2, 3, 2. And we are given the image. We are not given the point. But we know that we multiply the matrix by the point to get the image. The fact that you are given the image does not mean that you are supposed to multiply the 2 by 2 matrix by the image. Okay, so we multiply the 2 by 2 matrix by the point and we are getting the image. So now, how do you multiply the 2 by 2 matrix by the point? That is the column matrix. It's 1 times A plus 2 times B. Then it's 3 times A plus 2 times B. So we have 1 times A will give us A plus 2 times B will give us 2B. 3 times A will give us 3A plus 2 times B will give us 2B. And this is equal to 8, 12. Now, you realize that the equality also exists between the left and the right. And now with the equality of matrices, two matrices are said to be equal if only their corresponding entries are the same. What do you mean by that? It means that the first row can be equated to the first row. The second row can also be equated to the second row. So we have A plus 2B equals 8. And this one will be our first equation. Then we have 3A plus 2B. And this will be equal to 12. And this will be our second equation. Now what we have here is no more matrices again. It's now simultaneous equations. And so when we solve this, you will get the value for A and the value for B. Now, solving this simultaneously, we have the elimination approach, we have the substitution, you also have the graphical. And now, let's try to use the elimination approach. Now, when you refer to my videos on simultaneous equation, you understand what we are going to do here. So, in using the elimination approach, you can see that the coefficient of the A term, they are not the same, but the coefficient of the B terms are the same. So when we subtract one equation from the other, we can eliminate the B term so that we'll be able to find the A. That's why I say we are using elimination. You can also use substitution by making one of the variables the subject. You substitute in the other equation to find the other variable, then you send it back again to find the first variable. But now let's try to use elimination to solve this. So we have equation 2 minus equation 1. That means that we are subtracting equation 1 from 2. That's the meaning. So 2 minus 1 means we are taking 1 from 2. Now, if we are taking equation 1 from equation 2, then this is going to be 3A minus A. Then this will be 2B minus 2B. And this will be 12 minus 8. Now 3A minus 2A, 3A minus A will give us 2A. Then 2B minus 2B will give us 0. So we have 12 minus 8, and this will give us 4. So 2A will be equal to 4. In making A the subject, you divide through by 2. That's the coefficient of the variable, the A term. And then we have this is gone. The 2 into 4 will give us 2. So the value of A is 2. But we are not done yet because the point is A and B. So we are left with B. Now after finding the value of A to be 2, you can substitute this value in any of the equations and you can get the value of B. Now from equation 1, we have A plus 2B equals 8. Now A is 2, so we have 2 plus 2B equals 8. So grouping the constants on the right hand side, we can say that 2B here is equal to 8 minus 2. And 8 minus 2 will give us 6. But because we need to find B, we need to divide through by 2. So On the left hand side, divide by 2, you are left with b. Now 8 minus 2 is 6, and 6 divided by 2 will give us 3. That means that the value of b is 3, and the value of a is 2. The value of a is 2, and the value of b is 3. I want to explain this to you so that you know what you are talking about. Now we have 2b here equals this 8 minus 2, and the reason why this 8 minus 2, now you can see that if you have a plus 2b equals 8, and now a has given us 2, so we have 2 plus 2b equals 8. We need to make b the subject, so we group the constant either on the left or the right. Any of them you get the same answer, but we want to take 2 to the right hand side. Taking 2 to the right hand side becomes minus 2. What is really happening is this: we are subtracting 2 from both sides. Whatever we do to the left hand side, we do the same thing to the right hand side. So if you subtract 2 from the left hand side, then 2 minus 2 give us 0. Then we are left with 2b here. And when you subtract 2 also from the right hand side, it will be 8 minus 2. That's what really happens. So when we say that 2 on the left is now minus 2, that's what we are talking about. That's the meaning. So we have 2b equals 8 minus 2. So 2b will be equal to 8 minus 2 is 6. In making b the subject, you have to divide both sides by the constant attached to the b. So we have divided by 2, and our b is equal to 3. That means that the image, the point AB is now 2, 3. So the point AB is now 2, 3. So we said that the point should be PAB. So P is now 2, 3. If you remember the first question we saw, we said we were given the matrix and the point. You have to find the image, and this is what we had. Now we are given the matrix. We are not given the point, but we are given the image. But after solving, you see that we are getting back the point. You can go back and see that this was the point we were given, that we transform under this matrix and it give us this image. You see that we are getting the same point again. So that's really what is happening. When you multiply the matrix by a point, you are getting the image. Now we are going to consider another case where we are given 2 points with their respective images to see how best we can also find the matrix. To see how best we can also find the matrix. Okay. Now we want to generate the question ourselves. So I want you to understand what we are doing. So assuming the matrix A equals 1, 2, 3, 2. Don't forget that when we were given the point 2, 3, when we were given the point, that is P, 2, 3, when we were given the point 2, 3, we had the image to be 8, 12, because when you multiply the matrix by the point, you are getting an image. Okay, now I want to show you something, because I want us to be able to bring out this when you are giving points. So the first point give us an image of 8, 12. Give us an image of 8, 12. Okay, so let's assume that we have another point, and the point is the other point I'm talking about. Let's assume that we have another point Q, and the other point Q is 1, 2, and we have to find the image, and the image is not known, and let's assume that it's AB. Okay, so I guess by now you understand. Now we are given the matrix. The matrix is A equals 1, 2, 3, 2. Okay, so 1, 2, 3, 2 multiplied by the point, that is 1, 2, will also give us the image, that is AB. Okay, to simplify this, you are going to have 1 times 1 plus 2 times 2, then 3 times 1 plus 2 times 2, and this will be equal to AB. So we are going to have 1 times 1 is 1 plus 2 times 2 is 4. Then 3 times 1 is 3 plus 2 times 2 is also 4. And this is equal to, we have AB. So this is 1 plus 4 is 5, and 3 plus 4 is 7. And this is equal to AB. So the image Q prime, the image AB is now 5, 7. So when we write the 5, 7 here, I want you to understand what we are doing. That's why we are generating our own question. So we are 5, 7. That means that if you transform this point under this matrix, you get 5, 7. If you transform 2, 3 under this matrix, you get 8, 12. Okay, so now let's assume that we are not given the matrix A. And the matrix A is rather A, B, C, D. So how do we get the matrix? How do we get the matrix when we are given 2 points with their respective images? So the image of 2, 3 is 8, 12, and the image of 1, 2 is 5, 7. So how do we get the matrix? Let's assume that the matrix is A, B, C, D. So solution, you know that when you multiply the matrix, that is A, B, C, D, by the point, and the point is, first point is 2, 3, we are getting the image, and the image is 8, 12. So when you simplify this, in simplifying this, we have A times 2 plus B times 3. Then we have C times 2 plus D times 3. So A times 2 will give us 2A plus B times 3 will give us 3B. Then C times 2 will give us 2C plus D times 3 will give us 3D. And this is equal to, we have 8, 12. So we are now equating the corresponding entries. You can say that 2A plus 3B is equal to 8. That is our equation 1. Then 2C plus 3D is equal to 12. And this is our equation 2. So now, remember that the first equation is in terms of A and B. And the second equation is in terms of C and D. So we cannot solve these two simultaneously. So now, we are giving another point again. The point is 1, 2, and the image is 5, 7. So we multiply the matrix A, B, C, D also by the point 1, 2, and we equate to the image 5, 7. Now we are going to have A times 1 is A, then B times 2 is 2B, C times 1 is C, and D times 2 is 2D, and this will be equal to 5, 7. So we can also say that A plus 2B is equal to 5. Then C plus 2D is equal to 7. This will be our equation 3, and this will be our equation 4. So you can see that we have 4 equations now. Now the first equation is in terms of A and B, and the second equation is in terms of A and B. So you can solve equation 1 and equation 3 simultaneously. Then you can also solve equation 2 and equation 4 simultaneously. And when we do that, we will get the matrix. When you do that, you will get that particular matrix. So now let's see how best we can solve these equations. Let's see how best we can solve these equations. Now the first equation is 2A plus 3B equals 8. And this is our equation 1. So we solve equation 1 with equation 3. That is A plus 2B equals 5. This is equation 3. Then the other equation is 2C plus 3D is equal to 12. This is equation 2. Then we have C plus 2D, and this will be equal to 7. And this is equation 4. So when we solve equation 1 and 3 simultaneously, you get the value of A and the value of B. Now, the value of A after solving will give you 1. And the value of B will also give you 2. Now, when you solve equation 2 and 4 simultaneously, the value of C will give you 3. But the value of D will give you 2. So, if you are now trying to write down the matrix, remember the matrix was A, B, C, D. So A is now 1, B is 2, C is 3, and D is 2. So you realize that we are getting that same matrix. We are getting that same matrix we are talking about. We are getting that same matrix. And so the matrix A equals 1, 2, 3, 2. And I guess you understand what is really happening here. When you solve this simultaneously, you are getting A to be 1, B to be 2, C to be 3, and D to be equal to 2. And that will be all on this episode. In our next episode, we will try to see how best you can solve this problem so that you can understand simultaneous equations. That will be all for now on this episode. Thank you.